In this section, we're going to talk about entropy. There is a tendency in nature to proceed in a direction that increases the randomness of a system. A random system is one that lacks regular arrangement of its parts. This tendency towards randomness is called entropy. Entropy can be defined in a simple, qualitative way as a measure of the degree of randomness of the particles in a system. Let's look at the states of matter. In a solid, the particles are fixed in position in their small regions of space, but they are vibrating back and forth. We can determine with fair precision the location of the particles. The degree of randomness is low, so the entropy is low. When a solid melts into a liquid, the particles are still very close together, but they can move about somewhat. The system is now more random, and it is more difficult to describe the location of the particles. In this example, the entropy is higher. When the liquid evaporates into a vapor or gas, the particles are moving rapidly and are much further apart. Locating an individual particle is much more difficult, and the system is much more random. The entropy of gases is usually higher than that of liquids or solids. Some more fun facts about entropy. The entropy of a pure crystalline solid is 0 at absolute zero. Absolute zero is negative 273.15 degrees Celsius. What this means is if you were to cool some solid, a pure crystalline solid, all the way down to absolute zero, we think that the molecule would stop moving. If it stopped moving, we would be able to tell exactly where it is, which means its entropy would be as low as possible. That's where they came up with the zero. As you add energy to anything, the randomness of the molecular motion increases. The values for entropy are joules divided by moles times Kelvin. Just like enthalpy, entropy is defined as the difference between the entropy of the products minus the entropy of the reactants. So solving these kind of problems are the same as solving enthalpy problems. An increase in enthalpy, an increase in the randomness, is represented by a positive value for delta S. A decrease in entropy, or to have a less random environment, is represented by a negative value for delta S.